So it says that if we have lead nitrate and sodium, let's see, where's that? That's chromate, sodium chromate. What mass of sodium nitrate can be produced? So here's the equation. And we're going to put the lead with the chromate. And we're going to put the sodium with the nitrate. Notice, please, that the subscripts only travel when they're actually part of a polyatomic ion. Okay? This subscript is not, this 2 here, is not part of a polyatomic ion, so I didn't put it over here. This subscript is not part of a polyatomic ion. I didn't put it over here. This subscript is part of the polyatomic ion, so I did move it over here. And if you look on your common ions list, you'll find that formula. CrO4 is chromate. It's right there. Okay, so that 4 does travel. This is nitrate. Let's see, where is nitrate? Is right here. So it does travel as well. That 3 travels. All right. We need to balance the equation. I'm not sure. As the problem is written, you really don't have to find the physical states. Wouldn't hurt if you did, but the problem doesn't require that because it just asks you how much you're going to get of a certain product. Okay, it doesn't ask you how much of the solid. It just asks you how much of a certain product. So I'm not going to try to write the physical states here. Okay, it's not necessary. But we do have to balance the equation. Pb, NO, Na, Cr. And we call this an atom inventory. Okay. So how many leads do we have? How many nitrogens? 2. How many oxygens? 6. Sodiums? Say what? Right. 6 plus 4 is 10. Okay. So how many sodiums? How many chromiums? 1. Okay. You see we got the 10 there? Alright. Over here on this side, how many leads? Sodiums? 1. How many oxygens? 7. How many sodiums? How many chromiums? Okay. We want to try to get both sides to be equal, and we're balancing the equations. We always save oxygen for last. Start with the nitrogen, maybe? Alright, we start with Na. So there's 2 on this side, 2 on this side. 1 on this side. What do you do to get 2 on that side? Okay. Let's recount everything then. That's changed here. 2 sodiums. And how many oxygens? 10 now. So it's balanced. Alright. So in the problem here, we're starting with 12 grams of each reactant. That means we got 12 grams of this and 12 grams of this as well. Okay. So what we first have to do is figure out what's our limiting reactant. So we have to pick one of these 2 to start with. Does it matter which one to you guys? You want to start with this one right here? Okay. So let's start with 12.0 grams of Na2CrO4. How do I get from grams to moles? Molar mass. I heard somebody say it. Okay. When I have sodium, chromium, and oxygen. Right. Okay. So he said he already knows this from memory, having used it so much. And there's 4 oxygens. So sodium is 22.989. 769. And there are 2 sodiums. And then chromium, 51.9961. And there's only 1 chromium in the formula. I put 2 down here. There's 4 of these. Okay. And so 22.989 765 or 769? That's 45. .979 538. Chromium is just what it is, 51.9961. And then oxygen is 15.9994. 63.9976. I'm going to add all those together. Now notice there's a couple empty slots over here. Alright, so all these numbers, add them together. .973, 161.973, 238. We round off the last 2 digits over here. I get 161.973 grams of sodium chromate equals 1 mole of sodium chromate. Okay? Alright, that allows us to, that gives us what we need. This equality statement is needed for this, to convert this from grams to moles. We need that to build a conversion unit. So we're going to put the side of the equality statement here that matches the units and species in our starting amount on the bottom. We're going to put this then on the bottom. And this side goes on the top. Okay, we're always got to go through Moleville, and this is going to get us to Moleville. We're going to cancel grams because they're the same on the top and bottom, and sodium chromate's on the same on the top and bottom. Okay, so we now have moles. Now we're ready to go from moles of this to moles of the other thing we're looking for. In this case, the other reactant. Now, in the balanced equation, there's one of these. I'm sorry, one of these. There's a number 1 here implied, and a number 1 here implied. So we're really lucky because this gives us a 1-to-1 ratio. It makes the math a little bit easier. So we want to put this on the bottom, 1 mole from the implied 1 here of Na2CrO4, and then 1 mole of the lead nitrate on the top. Okay, now, again, we can cancel moles and the sodium chromate. Okay? I'll tell you what, why don't we have everybody stand up and stretch a minute? Everybody stand up and stretch a minute. Everybody. If you see somebody who's not getting up for me, tap them on the shoulder, let them know to get up. Stretch a little bit.
This class is hilarious. I'm not going to miss you guys. I just kidding. I don't miss some people in here. Like, I'm just saying, who's on our line? So I'm gonna mix everybody.
All right. Let's finish this up. Now that we have moles of this, we need to know the mass. Now that we know the moles of this stuff, we need to know the mass. How do you get from moles to mass? Molar mass. So let's do the molar mass then down here of the lead nitrate, lead 2 nitrate. You got lead, nitrogen, and oxygen. Okay, so lead is 207.2. Nitrogen is 14.0067. In the formula, we have just one lead. We have how many nitrogens? Is anybody here with me joining in the process? 2 of them. All right. Richard, Manuel, let's get up, please. How many oxygens do we have? 6 of them. Okay. There are 6 oxygens here. All right. 14.0067 times 2. Oh, I did something wrong. Times 2. 28.0134. I'm keeping the decimal place lined up vertically. Okay, and then we got 15.9994 times 6. Notice there are empty slots above these last 3 digits over here. That's important because I'm going to have to underline the last 3 digits and round off. Manuel, would you do me a favor and take your books and go stand at lab table 2? And then we're going to add all these numbers together. And we get 331.2098. And we underline the last 3 digits. And round it off. So we get 331.2 grams of lead 2 nitrate equals 1 mole of lead 2 nitrate. Okay. All right, now that we have that equality statement here, we have what we need to build a conversion unit up here. I want to have the side of the equality statement that matches the previous number set. This number with units and species. And this is the side that has the same units and species here. So I'm going to put 1 mole on the bottom. And put the grams on the top. All right. And we can cancel. So we're ready to do the math now. So we want to do 12 times 331.2. Okay. And then we want to hit divide. I hit equals or enter here. Now I want to divide by this number. Divided by okay, and I got 24.537.4229. Units are grams. Species is lead 2 nitrate. We want to round it off to how many digits? Well, I got 3 here. So that's 24.5 grams of lead 2 nitrate. Okay? Now, that's the first step. Okay? This is how we figure out what our limiting reactant is. If the amount we calculate here is greater than the amount given, this is the limiting reactant. And how much of this species was I given in the problem? 12. So this is clearly more than that, isn't it? That means that this is our limiting reactant. So the next calculation starts with the given amount of this. So we're going to start with 12.0 grams of this limiting reactant. Alright, now the problem is asking how much of the sodium nitrate. Well, that's this stuff right here. Here's the sodium nitrate. How much of that am I going to make? Okay? So now I'm going to go from this species to that species. Yes. Yes. Not right now. Isn't somebody? No, I guess he went to the nurse, didn't he? Okay, you can go to the restroom. All right, now I already have the molar mass. I've already done it down here. Okay, I don't have to calculate it again. I can just use those numbers. Again, grams of lead nitrate need to go on the bottom here because it matches grams of lead nitrate over here. And the other side of the equality statement down here goes on the top. What?
You like this?
The chemistry teacher, you like it. Chemistry teacher. You must do to be a chemistry teacher.
I'm just saying that's a lot, right? You got to do it 24/7.
It's the nature of what we do.
So you used to doing this like that.
So it's your nature.
It's the nature of what we do.
I get tired of just looking at it.
Well, it's the nature. I mean, the thing is, you've been learning math all these years. This is a chance for you to actually apply it. Actually use it for something. Listen, let me tell you something. This is business and industry. They look for people that can apply math. There are industries around here, and I've been to these industries and I've seen these classes. They hire math teachers to come in and teach kids how to teach their employees how to apply math. Because they get out of high school and don't know how to apply math. Okay? Basic math. They do a lot of calculations in most manufacturing operations. You know, they don't have manufacturing operations where you just punch a button or put a part on them and, you know, crank it down. They have robots. And people have to do the calculations to make everything work right.
Because how many students you got? I was just saying, like, I know you get tired of seeing the same thing over and over again.
Well, listen. Yeah, it can be tedious, but here's how I look at it. Here's how I look at it. Every day, every single day of my working life, I'm helping students prepare for their future. Now, I can't think of too many things that I can get paid for that are more important to our country and the people around me, my community I live in, than that. I think of it as being pretty doggone important. Now, a lot of people don't. I read stuff about how teachers are lousy and no good in this country and stuff like that, you know, and students that complain all the time. But the way I look at it, this is stuff you need, whether you realize it or not. You can complain all you want to, but when you're grown and have to pay your own bills, and your job is paying you less than your bills, that's not a good thing. You know, if you got to live in a ratty trailer somewhere because you can't afford anything else, that's not good. I helped deliver meals at Thanksgiving to some of the rattiest places in Spartanburg County, and it's sad. It hurts my heart to see kids living like that, and their parents are doing the best they can for them. And those kids are just like you. Some of them come in here and they complain about having to do the work. Where are they going to be when they grow up? Just like that. That hurts. That hurts me. Okay? I'm trying my best to teach you how to apply math. It's a basic skill, and there are very few jobs anymore where you don't need it. You know, it used to be, couldn't do math, couldn't do English, you could flip burgers. Robots flip burgers now. Used to be, you could dig ditches. Robots dig ditches now. It's people that can solve problems that have jobs. People that can't solve problems, they have a tough time of it. Those kind of jobs that don't exist now, much less in your future. So you need to learn to solve problems. It's what makes humans different than robots. The ability to be able to use your brain in a creative fashion. Okay? I mean, if you're a Christian, I guess you believe that humans are higher than lower animals, don't you?
What?
Not really? There's something that makes us different than lower animals, right? Well, if you don't believe that, that's fine. But if you do, then what is it that makes us different? The ability to be able to think creatively. That's it. That's right. Some people don't use it. Okay? Now, if you may have a different belief, and that's fine. I'm just saying, I'm trying to, since this is this is part of the Bible Belt here, a lot of people go to church. Okay? They call themselves Christian. I'm just trying to relate it to your experience. That's all. If you have another religion, please don't be offended at what I'm saying. I'm just trying to tie it into most people's experience. Okay? All right, let's keep going here. So we've got this in the moles. Now we need to get it in the moles of this stuff. Okay, the stuff we're looking for. All right? So the ratio here is 1 to 2. 1 mole of the lead nitrate and 2 moles of the, wait a minute, are we looking for that? Yes, sodium nitrate. 2 moles of the sodium nitrate. Okay? Cancel units. Cancel species again. And now we need to find the molar mass of this in order to get back to grams. I don't know if I might just kind of squeeze it down here, folks. So, yeah, we got it over here already. We just got to do the math here. Na 22.9896769 times 1. 22.9896769. Nitrogen 14.00. And there's one of those. And there are 3 oxygens. $47.9982. Got 2 empty slots on the end. and I get 84.994669. Going to round that off. I need to get rid of the last two digits here. 84.9947 grams of sodium nitrate equals 1 mole of sodium nitrate. All right. From this equality statement, we're going to build this conversion unit. Moles go on the bottom to match moles here. NaNO3 goes on the bottom. Those are going to cancel in a minute. And this was 84 here. 0.9947. Moles and sodium nitrate cancel. Do the math. Okay, so we want 12.0 times 2 times 84.9947. Going to hit enter and then hit the divide button and put in 331.2. I don't need to do division by 1 because that gives us the same answer we started with. So I get 6.15903 6263. I'm sorry, 6232. And that's grams of sodium nitrate. Look at our problem, and I've got 3 digits here, 4 here, 1, 2, 3, 5, 6 here. So I need to have 3 digits that match the smallest number in the problem among the measured or calculated numbers. And that's 3 digits. So I'll underline that. Draw an arrow, show I'm rounding off. 6.16 grams sodium nitrate, and that answers what the question is asking.